Hi, everyone. Thanks for joining us today for a 30-minute conversation with John Carrier titled Industrial AI That Works, Strategy, Survival, and Success, hosted by MIT Sloan Executive Education. My name is Diane Abbott. I'm an Associate Director with Executive Education. To let us know where people are joining from, can you add into the comments where you're calling in from? We'd like to know how much space we're covering. Great. Today, we're joined by John Carrier, who is a senior lecturer of system dynamics at the MIT Sloan School of Management. John has more than 15 years of experience in a variety of corporate, entrepreneurial, and consulting environments. Welcome, John.
Great. Thank you so much, Diane, and welcome, everyone. It's great to have such a great group from all over the country as well as the world. And would like to spend our time together today talking about really the practical aspects of industrial AI and how to start realizing some value while we're also learning to adopt this new technology. So a little background on me. I'm a control system chemical engineer by training. And so I really approach new technologies, including industrial AI, as a control problem, not just a shiny new technology. And why that's so valuable is if we approach it with that control aspects, we'll know where to put the technology into our system so that we actually see the value. And I'm half my time I spend teaching at the Sloan School, both the students and in executives, but the other half I'm actually out in a variety of environments, including oil and gas, process refining, just automotive and aerospace manufacturing, and even some software and back office processes. So I have a lot of experience out there in the field actually trying to get the value out of this. And we're going to look at today at how system dynamics and systems thinking, which was really created at MIT over 60 years ago, is going to give you and your company the advantage when it comes to adopting new technology. So I'm going to run through a few slides for about 15, 20 minutes, and then I would love to stop and get your questions and thoughts as we go through the presentation. Okay. So what do we need to know as leaders? First, we really are moving into the results phases of industrial AI. Now, second, this technology is available to everyone. So winners will be determined not by who has access to the technology, but whose organization adopts it faster in a way that actually helps its system. That leads us to the next question is how do leaders find that profitable path where learning and earning are actually balanced so that you have a sustainable path to success. And then we'll start thinking about how MIT increases your probability of success as a leader. So first, what is industrial AI? And I use this definition from NVIDIA. Jensen Huang, who we all know now in this world, was really leading both this transition to industrial and physical AI more than 10 years ago, where we're basically including every type of measurement into optimizing a system. So video, predictive analytics, sets of sensors, LLMs, the whole package. And we always try to jump in to optimize our systems, but before you can optimize and move to this magical world of industrial AI, we first need to understand our system. And just to let you know that physical AI is becoming a reality, I'm going to show you two schematics of plants. Now, all of us who've worked in operations, these should look very familiar to us. On the left, that's actually a Corning plant that's manufacturing glassware for basically the video industry. And you'll notice when they look at their own system, they're looking at in their own facility where they have adequate data and where they have inadequate or no data, and also where they're running simulations, probabilistic and quarterly econometric models. And one on the right is a startup company that came out of the Media Lab at MIT. It's called Tulip. And you'll see they have a very similar view of when you're looking at your factory system, how do we know what's going on at any one time so we can synchronize all the activities? Now, you ready for the shocker? The Corning facility on the left was actually for televisions in 1971. And what we're seeing on the right is 2026. So one thing to realize when we're starting to adopt industrial AI, we have to understand the needs of our current system. So your deep understanding of how systems and operating systems actually work is critical in successfully adopting industrial AI, and it's something we specialize here at MIT. Just as an example, one of my colleagues, Professor Richard Bratz in the chemical engineering department, he was asked by a major pharmaceutical company to help them design a new pilot plant using digital twins rather than the traditional methods. So what does that mean? He and his small team really carefully modeled out a digital simulation of how that process would work, not simply how the chemical reactions would work, but also the physical layout and control systems, which you can see in the left. And when they use this digital twin approach in design, they reduce the cost of the actual design to build by over 50%. So we're talking 50% less physical equipment to purchase. Second, they reduce time to market by 50%, which if you have a drug on patent, that matters a lot because that's your profit margin. And third, it only took up the third of the space, the floor space. And now in operations, that digital twins, which is incredible high fidelity, actually resulted in the first time they started up, they made high quality product. That's never happened with this company before. Now that digital twin runs continuously with operations, right? So you can maximize production while maintaining exceptionally high quality control specs. So this is an amazing success story. The technology is here, and it's already changing the way companies compete, especially in industries where time is really expensive. And I think one way to think about digital twins, it changes the economics of mistakes. If we can make mistakes in a digital world and debug those before we actually physically commit, what we can actually achieve is far superior than our current methods. Second, at MIT, we're looking at maximizing the human performance through connecting to this physical AI world. And I'd like to show you how I teach lean operations to my students at MIT. How do we actually incorporate some of the new AI technologies into that? I'm going to show you a short 10-second video. And I had my students change a tire, right, which is a classic lean operations exercise, but use some of the new technology coming out of MIT's Media Lab. So let's take a look at that.
This project focused on improved overall workflow.
And you'll notice that my student, the technology is actually mapping his movements.
We also in the process reduced the
And
tag time by 55%.
they were able to use this data to build a value stream and reduce the time from 500 to 250 seconds. So if your company's already doing operational improvement with human beings, it's time to jump to these new technologies where you're actually mapping people's their ergonomics, their moving space, and wasted motions.
This project focused on improved.
And if we actually take another view of what the technology does, if you see those green, yellow, and red lines, that actually shows the movement of my students through that space. And every time they walk away from one of those stations, they're not building something. So it's a really good way to find waste and move away from pencil and paper into this physical AI world. And you know what the best part is? You can do it with just your iPhone, right? It has all the technology you need to actually map out your own physical space and re-energize your organization's lean and continuous improvement methods. Now, I'd like to jump to an example on agentic AI. This is one I personally helped two of my students find 1 million cases of beer per month extra in Mexico's largest brewery. And how did they do it? Through agentic AI. One of the things that my students learned when they started looking for time delays, which is a very deep systems dynamics concept I taught my students, they found that it took 6 hours to do a changeover, but there was only 15 minutes worth of information. So just by building a relatively simple AI agent that when targeted could reach out and grab data from the machine from the cloud and also get it to the maintenance immediately, they were able to shrink that from 6 hours to 15 minutes. So a couple interesting things to learn here. This is a relatively simple agent, but it actually changed the way the work is done, not simply improve the workflow. And a little bit of Back to the Future here. Many of you might have been familiar with the whole business process reengineering idea, which came from the 90s. And it's really not about improving our workflows. Let's use this new technology to completely change it. And by the way, to point out, Michael Hammer was an MIT computer science professor. So this beautiful principle still works when you go out to apply AI. And if you're not thinking about using the technology to actually change your workflows, that's probably why you're only getting 20% of the value. And just as a framework that we'll go through the class is find the problem, then pick the right agent you need to deliver the value. There's no reason to jump to a level 5 agent when a simple rule-based agent will do. But if we do need large language models, which I'm now seeing very common, the ability to build an agent using a large language model is really where the next cutting edge is going to be in the next 6 months. So as we start to get a key insight, from Jay Forrester, who created the System Dynamics group here at MIT, there were some missing feedback loops here, right? And that AI agent was designed to build a shorter, faster corrective feedback loop. That's why the value was learned. So it's not simply about building AI agents. It's about using them to replace long, slow feedback loops with very fast ones. A quick example of how this actually works. John Seeley Brown, who basically developed the technology for the Macintosh while he was at Xerox, when he actually talked to Xerox copy machine repair people, he wanted to know how they did diagnosis. So how do you go out and fix a copier machine? And I think this will surprise you, is the answer was the first thing they do is go look in the trash can next to the broken copier, right? And pull out crumpled copies. Why do you think they do that? Because that's where the information that you need to do the diagnosis is located. So when you go and start wanting to apply these new technologies, start thinking about where that information is pooling and then build your agent there. And there's always a human in the loop, but how do we actually put the AI agent with the human to shorten that delay time? Okay. Then when we start thinking about shiny technologies, as a leader, you need to be careful that you actually buy something that actually changes your organization. And one of the ways you change the way your organization performs is the speed at which it makes good decisions. So as we talk about industrial AI, all of the technologies that we're going to show during the course, from augmented reality, physical AI, video analysis, large language models, agentics, and multimodal, that includes Gen AI, we're going to put in this framework as how did it make our system perform faster? This comes from Colonel John Boyd. It comes out of the Air Force, but the message is, if you want to beat your competitor in a military action, your speed or time constant, which is tau s, has to be faster than your competitor. Now, if you're actually in a business that serves a customer, your speed to serve has to be faster than your customer's speed to purchase, right? So if you get the product or service to your customer faster, they will buy from you over your competitors. It's broken into 4 pieces: observe, orient, decide, and act. It's something we'll go into much more detail in the course, but I see this mistake that companies are making when they go to invest in technologies. They invest in, let's buy things that act, right? That show energy and make things happen, because that's very visual and attractive. But when you invest in action, you really should have been putting more money in better observation and orientation, better sensors, better data, and for the orient stage, using better models to take that observational data and actually frame it into something that can make a good decision. So as part of the course, you're going to probably start to reallocate where you're investing your AI money from ACT and start pushing more into observe and orient. And just as an example, is data's great, but it can be very expensive. So one of the things that some of our students here did at MIT was start creating something called synthetic data, because training these models requires 50, 100,000 photographs. So this was one in a very quality sensitive area. It's syringes, right? And we make hundreds of millions of these a year. How do you inspect all of them with 99.99% quality? Well, it turns out, as you'll see in this photograph, you don't even make defects. The process is so good. So how could the system ever learn when defects are so rare? So you'll notice on the left, see the bubble there that's small? That's a fine, acceptable meets quality. But what does one look like where they actually did not put enough liquid in? You get a larger bubble. Believe it or not, that defect was created by synthetic data. And that's what allows us to train these neural nets very quickly without having to get hundreds of thousands of defects. Really spectacular example. I also want to say a cautionary tale is you can also absorb too much data. So this is a refinery I actually worked at about 15 years ago. Unfortunately, recently there was a tragedy where there were 2 fatalities and the system was completely overloaded with safety alarms so that the information flow actually ground to a halt, right? And one unsent email led to some of that tragedy. So as we start to jump into this exciting world about getting more data and getting better context so we can make better decisions, by using this OODA loop and system dynamics thinking, we're going to realize what data do we want, where does more data actually hurt us, and does it actually get us away from a culture of just large data lakes to a culture of collecting good data that's leading indicators. This also has implications for industrial robotics. This is Rodney Brooks, MIT professor, very famous for his works in robotics. But I just wanted to point out where his thinking's changed in 12 years. He created Sawyer, which is a pretty complex robot that could do all sorts of things and really flexible and it's very general. But many times industry just needs something very simple robot that's designed to do one specific task over and over again. This is his new company in 2024. And you see it's just simply moving materials back and forth in an intelligent way. But that's the one that's having the impact. So just to support as we start on our AI journey, just a word from Andrew Ng, who's a Stanford professor who's very well known in the AI circles. Even he, after 10 years, has said we need to unbig AI. So as part of this course, we're going to give you the right tools and frameworks so you can scope down from a big AI transformation into a set of sequence steps, each one of them that will show success and ROI. And just some support from that, even Microsoft, right, with its Copilot 365, had to bring on someone who understands deep manufacturing. She came from GE. And because she worked with Larry Culp-Danaher, she brought along the Japanese concept of Kaizen, which means we have to break things in small problems and we have to work together to solve those to add up to a big change. So even large companies like Microsoft, who really should have the most experience with their own technology, realize you must have a systemic approach if you want to drive adoption. We're also going to adopt the role of the role of culture in technology adoption. And when you actually look at organizations and systems, they actually generally resist change. And that is not all bad. Why is that? Because if we let everything into the system and change to everything, we would actually, it's almost like allowing cancers to grow in your system. Bad things would take root and bad consequences. However, so an organization system has to have a boundary to allow good change in and protect itself from bad change. And when you look at organizations, many of you will come from large organizations, which means you're bureaucratic. And the framework we're going to look at says, bureaucracy is run by rules. And when you have large rule-based systems, they can be very effective because they're bureaucracies. But what's highlighted here, we neglect bad news. So imagine you can have a bureaucratic organization. You can buy all this AI and get all the information and data you want, but the system will not listen to that message, right? And large systems struggle with changes. Novelty leads to problems. what we really want to move is not only from including a generative technology, but ensuring our organization is generative and performance oriented, so that when we start bringing in messages, our organization listens to that information and then novelty becomes implemented. And when we see a failure, we don't look for justice. We actually learn for inquiry and learning. So the cultural lens of adoption is going to be very important here in this technology. So let me just go to the course. So this is live online, and over the span of 3 days, first we're going to really root the course in. We're really not trying to buy just AI. We're trying to develop a robust, resilient operating system, and we're going to do that through the new sets of tools that we're referring to as industrial AI. Then the second part, I'm going to really bring in my 20 plus years of systems thinking as well as my colleagues, where if you actually look at the dynamics of how the system's performing, it will tell you where it's strong and where it's weak. So then we can match the new technology to the system's existing problems, rather than bringing in the technology and then trying to figure out how to get the ROI. And then finally, we're going to have a senior leader from a very high-tech industry with over 100,000 employees talk through his journey through the digital transformation. And it's a high-tech, it includes high-tech manufacturing. So it not only spans generative AI and agentic agents, but also gets into some of the visual quality systems and even includes high-tech additive manufacturing. Then on day 2, we're going to jump into looking at use cases from Industry 4.0 and industrial AI. And that will give you the opportunity to match what you'd like to see out of your organization to what some leaders are doing. Then Cyrus Shaul will be joining us. He's going to talk about visual intelligence in industrial AI. This is really one of the cutting edges, because now we can understand what's going on in our systems at any time, any place, by using cameras and pretty sophisticated video analysis techniques and reinforcement learning. And then finally, we'll also give a high-level review of the state of the technology, where CEO Matt Littlefield will talk about what leaders in the industry are doing. Then finally, on day 3, because we've covered the OODA loops in day 1, and we'll also reinforce it in day 2, we're also going to learn about the culture of information flow. So what is actually slowing down our adoption approaches? And then followed by that culture, we're going to spend a specific block of time talking about workflow acceleration and where Gen AI and agentic AI can make a big difference. Then finally, what we really want to achieve here is when you go to back to your work environment, that you've developed your own playbook to amplify your own organization's transformation, and then we'll wrap up with a certificate. So it's a pretty action-packed 3 days. It's not only filled with examples and key frameworks, but will also allow you as a group and a team to share examples and learn. So just to conclude before we have the opportunity to take some questions and comments from you, this is really about leading AI that actually works. So industrial AI creates value by improving decision quality over end decision speed. Gen AI, agentic AI, and physical AI are raising the stakes. And really, winning organizations treat industrial AI as not just a technology adoption, but a way to shift their operating system. Here at MIT, we have a long history of understanding artificial intelligence, system dynamics, and the dynamics of people and how we work together. And then finally, we also understand leadership, as does the group here. So thank you for joining me for basically a short introduction of what we're going to cover, and would be happy to take any questions or comments the audience might have.
Thanks, John. If people would like to add comments into the comments section, we'll review them and pull out a couple. I have one here from our participant, Lynn. How can we learn more about digital twins and how to create them?
Okay. So that is a great question. One of the things I've actually started in the late 80s and early 90s, when we used to call it modeling, right? Then we started using modeling and building pretty sophisticated models that actually ran in real time. right? So not just during the design phase, but in operations production. And now we stepped into this world of not only do we build them in the design phase, we actually run them in parallel, right, with the real operations. So one of the things we will cover some of that material in the course. And one of the things when you leave the course is I leave with for each session, a set of where to go to the next level to learn about digital twins. So one place I would start is start to look at what some of the vendors offer, look at what's popular in your industry. And what we'll do in the course is try to give you an overall framework so that you can see what digital twins are out there, understand why you need them, and where you should start your efforts.
Thank you. Here's another one. What are the most common pitfalls organizations encounter in industrial AI, and how can leaders deliberately avoid them to create lasting value?
I'd say the first one is, and this goes all the way back to the Greeks, know thyself. When you buy the new technology, it was not clearly thought out what value could be added. And this is easier than you'd think. So let me just give you, I showed that in the Heineken example, but I could show this. This is how I typically work at a company. Start with where's the value. So, I used to be a design engineer, and design engineers love to design things, right? So one place you could go look in your, what are your new engineers' equipment they're designing, and what are they trying to buy? Because they love to spend money. And in the Heineken example, they're going to buy 2 new bottling lines, right? In your system, they might be buying a new reactor. They might be buying a new machine to add capacity. Then go back and say, why can't we do this with our current system? And is this actually, we just don't have enough physical capacity? Or is it our current operations are actually running, there's 20% extra capacity there if we had better information? So go back and spend time where, one, look at your capital allocation and see if people are trying to spend money when they should be spending this. 2, look for where poor information flows are creating low utilization. And then 3rd, also look where sometimes in most places there's a lot of variation in how long it takes to do the same task, right? And that can result in a lot of value. And I will add this as finally, if your organization has a safety case, so it's a process or physical safety case, start there. Don't worry about the ROI, but because it will, right? Because safety will override ROI. But I guarantee you, if you take an unsafe process and you re-engineer it with some of these new technologies, you most likely will add an ROI because you just took a dangerous, slow process and by using information instead of people to actually do that task, you've not only reduced risk, but you've actually increased speed, which is value.
All right. Who sets the limits of industrial AI evolution? Human beings or AI?
I'm going to give you a short-term answer on that because and the short-term answer is right now. So what I've seen over the past 6 months, which I think has surprised everyone, is 10 years, even 5 years ago, trying to use reinforced learning and neural nets and all those things, the technology and resources, I think that was the limiting factor. Today, you can get all the data you want, you can get all the compute power you want. These models have been built for you. So I think over the next 3 to 5 years, especially in existing industries, our ability to adopt and absorb the technology are going to be the limit. But longer term, that'll be different. But I think that's the constraint right now.
Showing us how quickly things are changing in this world. This will be our last question, everybody. Many companies succeed with AI pilots, but fail to scale them, across the enterprise. From your experience, what are the key organizational barriers that prevent scaling, and how can companies overcome them?
Okay, so I have to start. I'm a chemical engineer, so scaling is really important to us because whenever you think of, we all know that when you grow a sphere, the radius, when it grows linearly, your surface area is by the square and the volume's a cube. So when I hear a lot of people talking about scaling things across organizations, they've actually given no thought to what that means. Right. And certain things scale at certain rates because of those rate limiting factors. So the first thing is I think everyone needs a fundamental understanding of what scaling means. right? And also realize physical assets scale at different rates than information. And then third, in order to make a big difference, to increase your profit margin by 5 to 10% is a massive change. So even by changing some of these less interesting things to scale those up can actually create tremendous value. So again, I think organizations actually need to understand what scaling means, and that scaling assets, physical assets, is different than scaling information. That's a great start.
Thank you, John. Thank you, everyone, for joining. If you'd like to hear more and dive deeper into these topics and more, please consider joining us for the upcoming course at MIT, Strategy, Survival, and the Success in the Age of Industrial AI. It will be running April 28th through 30th, live online, which is what John described earlier. We also have an on-campus option on October 1st and 2nd. Please visit our website to learn more and register. We hope to see you on campus or live online, and stay tuned in 2026 for more offerings. Thank you for joining. The recording
Thank you,
will
everyone.
be shared and
Hope to
emailed.
see you in April or October. Take care.
Thank you all.